Taking a look at the sea surface temperature anomalies over the entirety of the northern Atlantic, we do see that much of the northern Atlantic is experiencing sea surface temperatures that are much warmer than average, and that'll play a big role in terms of how many storms we're going to see this hurricane season, because of course if the water temperatures are a lot warmer than average, we're more likely to see a lot more lift to support for more tropical cyclones to develop. And we see that the warmest sea surface temperatures, at least compared to average, are located closer to the West African coast, to the western coast of Portugal, as well as Spain, where those areas are experiencing temperatures well above average in comparison to other areas of the Atlantic. But we're also seeing the warmer than average sea surface temperatures extend into the Caribbean as well. But we do have some pockets where the sea surface temperatures are currently cooler than average, such as the southern Caribbean. But the southern Caribbean doesn't really experience that many tropical cyclones developing in that area, and typically when a tropical cyclone moves into the southern Caribbean, it tends to have a difficult time maintaining its strength because there's a strong amount of wind shear typically in the southern Caribbean. So even though the sea surface temperatures are cooler than average in the southern Caribbean, that might not make a major effect when it comes to the amount of storms you're going to experience or the amount of landfalls that each area of the northern hemisphere will experience. And we do have pockets of cooler than average sea surface temperatures as well, just off the the east coast of the United States, where we're seeing the cooler than average sea surface temperatures towards the coast of eastern Canada as well. However, the current computer models are expecting that the sea surface temperatures will eventually rise above average, and we're going to see an interesting pattern that might cool down the sea surface temperatures just a little bit right around the main development region, which I'll show you guys right now. So here are the current sea surface temperatures throughout the entirety of the Atlantic. By the way, this is in Celsius. Don't go outside thinking that the ocean is 25 degrees Fahrenheit, because that's definitely far from the case. But in terms of the sea surface temperatures we're seeing right now, so anywhere that's in the yellows or in a color that's closer to red, that's where you are experiencing sea surface temperatures above 80 degrees. And we do see that the area is definitely expanding as we approach mid to late May, and then eventually we're going to see the 80-degree temperatures rise up into the northern Gulf of Mexico as well, where the temperatures in the northern Gulf of Mexico are still right around the upper to mid 70s, close to the 80-degree range, but not there just yet. So of course it's going to be very difficult for any tropical cyclone to develop with sea surface temperatures this cool throughout the Atlantic. There could maybe be that subtropical cyclone that does develop in the during the month of May. That has been a typical case in the past, where in the past, I think, few previous Mays, we've seen a tropical cyclone form very early in the year, in the which even though the sea surface temperatures are much cooler than average, but it's definitely going to need some subtropical characteristics to really attain to potentially enhance the chance of a tropical cyclone developing, or maybe it develops in the Caribbean. But right now we do see the main developed region still below 80 degrees, but expect the temperatures to quickly rise once you approach the month of June, where I'd say by late May into early June, the sea surface temperatures in the northern Gulf of Mexico should rise back up to above 80 degrees to definitely enhance the possibility of tropical cyclones developing as we approach the beginning of the hurricane season. So next, I want to show you guys what the consolidation of the computer models are stating when it comes to their forecasted sea surface temperature anomalies as we approach the main months of the hurricane season, which includes August, September, and October. And we do see that the main developed region is expected to be the area where the sea surface temperatures will be well above average. And this is concerning because during the month of August and September, as you probably know, that's where the most tropical cyclones develop. That's where the most powerful tropical cyclones develop, right over the main development region. And if we see the sea surface temperatures much warmer than average in that area, then we could be in for more tropical cyclones than you'd expect we'd see during an El Nino pattern. So I think this will play a big role in terms of the amount of storms we will experience this hurricane season. And we even see the warmer than average sea surface temperatures extend into the Gulf of Mexico as well as the Caribbean. And we do see the sea surface temperatures temperatures closer to average in the middle Atlantic. So this is where I'd assume the Bermuda High will be located, since the Bermuda High would be preferably in an area where the sea surface temperatures are cooler than average, where the air could sink without getting interfered by the upward motion that warmer sea surface temperatures promote. So it will likely be in this area, but most of the tropical cyclones, I'll say, will develop in the main development region thanks to the much warmer than average sea surface temperatures that are expected this year, at least compared to other areas in northern Atlantic. So that's something to keep in mind. We have to still take this with a grain of salt because, of course, computer models are far from being 100% correct most of the time. So we could still easily see the sea surface temperatures forecast change, but since this is combining several different computer models into one, and they're all pretty much agreeing that the sea surface temperatures will be much warmer than average in the main development region, I'll say more likely than not, we're going to see the departure from average be a lot higher in the main development region than other areas in the Atlantic. So I do expect more storms than average to develop in this area of the Atlantic. And now taking a look at the precipitation anomaly for the main development region in the main hurricane season months, which includes August, September, and October. And we do see that a lot of the computer models are agreeing that most of the moisture should be focused in the main development region just north of the Caribbean and extending into scenario 2 of how the Bermuda High would build, which pretty much is when tropical cyclones would move up the east coast rather than into the Gulf of Mexico. And what's interesting is that the precipitation anomalies are lower than average in the southern Caribbean as well as portions of the Gulf of Mexico. And like I've been saying in my previous forecast videos, when it comes to the exact trajectory of where tropical cyclones will make landfall and the exact position of where this ridge will be located in the Atlantic, I expect more tropical cyclones to move up the east coast rather than into the Gulf of Mexico, and part of the reason is because we're going to be in an El Nino phase, and that will definitely enhance the westerly upper level winds to the point where that's going to force a lot of tropical cyclones to move a little bit further northward rather quickly, rather than have the ability to move further westward, because the upper level winds will be so strong that it's going to deter a lot of tropical cyclones from being able to move westward thanks to the upper level winds. So I do expect more tropical cyclones move in this direction, so the east coast could be more at risk of a tropical cyclone making landfall this summer and into early fall. So make sure to pay close attention to that possibility, and combined with the fact that sea surface temperatures will be much warmer than average, that will certainly enhance the possibility of more tropical cyclones, even though we're in an El Nino pattern. So keep that in mind as we approach a hurricane season. So here is a line graph of the sea surface temperature anomaly for the Caribbean, and we do see that over the past few weeks, the sea surface temperatures have risen above average, and we're seeing the sea surface temperatures subside just a little bit as of recent. And I expect the sea surface temperatures in the Caribbean to mainly fall closer to average, because I do expect the southern Caribbean to experience either around average sea surface temperature anomalies or slightly below average anomalies. So I do think that it'll balance out the warmer sea surface temperatures you'd experience in the northern Caribbean, maybe slightly above average sea surface temperatures you should expect this hurricane season. But we do see that the temperatures are starting to subside just a little bit, and I'll show you guys why in just a second. But I do expect the sea surface temperatures in the Caribbean to mainly fall around average. Now let's take a look at the main developed region's sea surface temperature anomalies. So here's the same line graph, except it's for the Atlantic main development region, and we do see that the sea surface temperatures have risen above average as well over the past few weeks, but we have seen this drop in terms of the sea surface temperature anomaly as of, I'll say, the past week. And I'll show you guys right now, but I do expect the main development region to be the area where the departure from average will be the highest. So that's definitely a concern because that will enhance the possibility of more tropical cyclones this hurricane season. One big thing I want to show you guys is the North Atlantic oscillation forecast over the next few months. And you're probably wondering, how does this pattern that I typically use for the winter will affect the hurricane season? Well, to show you guys, typically during a positive North Atlantic oscillation, we see the sea surface temperatures actually become cooler than average for most of the northern Atlantic because it creates an upwelling right around the West African coast as well as the East Coast of the United States, since the winds are a lot stronger than average. At least the trade winds are stronger than average during a positive North Atlantic oscillation, but during a negative North Atlantic oscillation, we see the westerly winds as well as the easterly winds associated with the trade winds over the main development region. We see the winds a lot weaker, so that promotes less upwelling, and sea surface temperatures would be warmer than average since there isn't as much upwelling that's going on in the northern Atlantic and right up along the West African coast specifically. So to quickly show you guys what upwelling is, it's pretty much when the surface level winds move away from the coast. So that pushes the warmer water along the surface away from the shore, and what replaces it is the deeper and cooler water that moves up the coast, which brings the cooler water to the surface. And since during a positive North Atlantic oscillation, we see stronger easterly trade winds that off the West African coast, that pushes the warmer water off the West African coast further eastward, and that brings the cooler water up the coast, and then that overall makes the main development region experience sea surface temperatures that are cooler than average when we see a long duration of a strong easterly wind up along the West African coast. So that's something to keep in mind. To really show you guys the differences, here's a map of the negative North Atlantic oscillation and a positive North Atlantic oscillation, and we do see that during a negative mode, we see the jet stream winds are a lot weaker, and so the jet stream meanders a little bit more up northward and southward, and the ridge is a lot weaker, so the easterly winds are weaker, so we're seeing less upwelling up the West African coast. But in the positive North Atlantic oscillation, we see that the ridge is a lot stronger, the jet stream winds are a lot stronger, so that means the winds up along the east coast are a lot stronger, which means that we're going to see more upwelling along the coast in a scenario like this. And along the West African coast, since the ridge is a lot stronger, the southern winds associated with this ridge are stronger as well, which will promote more upwelling along the West African coast, and that would promote cooler than average sea surface temperatures throughout the main development region. In terms of the North Atlantic oscillation forecast, so we're expected to remain in a positive North Atlantic oscillation over the next few weeks before by I'll say the early June timeframe, we will fall back closer to average, if not slightly below average. So we might see a period where the sea surface temperatures will cool down just a little bit thanks to the stronger upwelling we're going to see with this positive North Atlantic oscillation. But after that, we should see mainly a negative North Atlantic oscillation. So we're going to see less upwelling, and as a result, we're going to see the sea surface temperatures likely stay well above average, and the departure from average could even get higher from this point as we approach the hurricane season, which is definitely a major concern, which is the reason why I expect the main development region to experience temperatures, the departure from average at its highest when it comes to sea surface temperatures. So here's my forecast when it comes to the sea surface temperatures for this hurricane season. So if you're in the red, this includes the main development region as well as just the areas just north of the Caribbean and just off the United States East Coast. I expect the sea surface temperatures to be much warmer than average, so that will play a big role and definitely enhance the amount of tropical cyclones we will experience this hurricane season. This is due to the fact that the sea surface temperatures right now are much warmer than average. I don't expect much upwelling to prevent the sea surface temperatures from falling below average. And plus, by the way, we're in a positive North Atlantic oscillation, so we're more likely to experience water temperatures that are much above average. So I do expect more tropical cyclones to develop this hurricane season than, let's say, if we were in a negative Atlantic multi-decadal oscillation. So make sure to keep that in mind this hurricane season, and make sure this because this will likely be closer to average this hurricane season, or at least bring more tropical cyclones than you'd see during an El Nino pattern. So make sure to definitely keep that in mind, especially if you're up along the East Coast, where I do expect more tropical cyclones to move this hurricane season rather than the Gulf of Mexico or the Southern Caribbean. But anyways, guys, thank you guys for watching. Make sure to subscribe if you want to see more weather related content, and I hope you guys have a great day.